Geometry lesson 4.5, continuing proving triangles congruent. Today we're going to talk three more theorems for that. All right, much like an included angle, an included side is a common side of two consecutive angles in a polygon. So PQ is included between angle P and angle Q. So that leads us to our next one. Remember from 4.4, we already have side, 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 and side, angle, side. Now we're going to add angle, side, angle. If two angles in the included side of one triangle are congruent to two angles in the included side of another, then the triangles are congruent. So angle, side, angle is another way to prove triangles congruent. Okay, so this kind of goes through a little proof on how that they prove that. Angle, side, angle with the third angle theorem, you can use angle, angle, side as well, because if you know that G and J are the same, then we knew that H and L are the same. So angle, side, angle also works. If you have angle, side, angle, you also have angle, angle, side. Okay, so that's our next one. If two angles in a non-included side of one triangle are congruent to the corresponding angles in non-included side of another, then the triangles are congruent. So angle, side, angle, or angle, angle, side. Just when you finish your proof, say AAS or ASA, depending on how you did it. Okay, so determine if you can prove the triangle's congruent. Well, you're given those two angles in each, and then they share that side for reflexive. So angle, angle, side works for both of those triangles. All right, what about here? Well, we share that side for reflexive. Now, we're parallel just here and here. Not the same, but parallel. So that and that would be alternate interior angles. We don't know if those two sides are parallel. So we don't know about these other two angles. So this does not work. They are not congruent. We do not have enough information to use any of our triangle congruence theorems. Okay, prove the triangle's congruent. 4 steps. Givens and proof. I think I've got, hold on a sec here. I think I've got the, no, I don't. Okay. Oops. Hold on. Let me go back. Okay. So we've got our 4-step proof here. So we've got our given. 1, 2, 3, 4. And then what we're trying to prove is going to come last. So we're going to try to prove this triangle and this triangle congruent. We're given that those two angles are the same. We're given that those two angles are the same. And we're given that XYs and VY are congruent. Okay. So we need another side or another angle. Well, I'm going to make my life easy here. I'm going to call this 1, 2, 3, 4. We know that angle 2 is congruent to angle 3 because they gave it to us. Well, what would angle 1 plus angle 2 and angle 3 plus angle 4, what would both of those have to add up to? Aren't those straight angles? So wouldn't both of those have to add up to 180? Okay, so they're supplementary angles or straight angles. Okay, well, if 2 and 3 are the same and 1 and 4 are the same, or excuse me, if 2 and 3 are the same and we both know that they both add up to 180, then 1 and 4 would have to be the same. And that is called congruent supplements. Okay, so we've got it. Now we know those two angles are the same. Angle, angle, side, angle, angle, side, to prove that our two triangles are congruent. All right, let's try another one, a little better one here. All right, use to prove the triangle's congruent. We got 4 steps again, so I'll kind of do that. There's our givens right there, and then we're trying to prove comes last. So we've got 1, 2, 3, 4. Okay. Well, we're trying to prove this triangle and this triangle congruent. Got a real easy one staring at us. JL is congruent to itself. Anytime we take that, that's called the reflexive property. All right. JL bisects angle KLM. So this bisects only over on this side. So we could say that those two angles, angle KLJ is congruent to angle MLJ by what? How do we know that? Definition of bisector. Bisector splits that in half. Okay? Then we've got it. Boom, boom, boom. Angle, angle, side. So we just proved those two triangles were congruent by angle, angle, side. All right. So a couple of examples of some proofs. So now we've got 4. We've got side, 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 angle, side, angle, and angle, angle, side. The last one is called hypotenuse leg, and it only works in right triangles. And if you can show the hypotenuse and leg of a right triangle are congruent to the hypotenuse and a leg of another triangle, then the triangles are congruent. So hypotenuse leg can only be used with a right triangle. You can still use some of the other ones in a right triangle, but you can only use hypotenuse leg in a right triangle. All right, determine whether you can use hypotenuse leg to prove the triangle's congruent. If you can't, tell us what else you need to know. Well, they were given this, and then they share that. So we've got a hypotenuse and a leg. So that would work. That one works. What about this one? Well, we're given this. We're talking about these two triangles here, these two right triangles. We do not know if the hypotenuses are the same. So that would not work. We don't know the hypotenuse for either triangle. Okay, what about this guy? Determine, so we've given those two sides, and then they share BC. So yes,